Hello and welcome back to another episode of In Our Element. My name is Nyomi Martinez and I am a Customer Technical Service Engineer here at Materion. Today I'll be briefly discussing CTE, or coefficient of thermal expansion. The coefficient of thermal expansion indicates to what extent a material expands as a result of a change in temperature. As we dive into CTE, it's important to understand why it's relevant. A low or high CTE isn't necessarily good or bad, it's just a material property. And as with many material properties, what's actually desirable depends largely on material application. A high CTE material, or a material that expands greatly with temperature increase, may be desirable in a thermostat or a thermometer. A low CTE material may be desirable in aerospace functionalities, where materials have to hold up over a wide range of temperatures. And now that we better understand CTE, how do we find it? Finding a material's CTE is pretty simple, as long as you're able to obtain initial and final temperature measurements, as well as any changes in length. Change in length is required for linear CTE, which is mostly what you'll find reported on datasheets. Area expansion and volume expansion can easily be found from linear expansion for isotropic materials. Otherwise, those measurements are going to require some additional calculations. Sometimes CTE is reported as a mean value for a temperature range, rather than a single value for a given temperature. How you choose to report CTE is up to you. Understanding thermal expansion is a critical consideration in many applications, and for good reason. No matter how great any material is, if its CTE is not compatible with or is dissimilar to its environment or any welded materials, things are likely to go awry. For a more detailed discussion of CTE, be sure to read the corresponding blog post available on our website at materion.com. And if you have any additional questions, please feel free to reach out to the CTS team. Thank you, and we'll see you next time.